Good morning, students. In the last class, I explained how to find out the empirical formula and the molecular formula based on the data we used. So, based on that, in today's class, we want to discuss some problems. Okay, this problem is very important for 3 marks. I'll go with the problem first. The first problem is right here. Important for 3 marks. That is calculation of empirical and molecular formula. Okay, this is the idea. I'll write the questions first. First question: a compound contains 4.07% hydrogen, 4.07% hydrogen, 24.07%, sorry, 27% carbon, okay, and 71.65% chlorine. Its molecular mass is 98.96 gram. What are its empirical and molecular formula? So this is the question. Okay, what it is? A compound contains 4.07% hydrogen, 4.7% carbon, and 71.65% chlorine. Okay, so in that, students, we have to calculate its molecular mass. The molecular mass is given, that is 98.96. What is its empirical mass and molecular? So empirical formula and molecular formula. So there are some rules, as I told you in the last class. Okay, first I'll write that, then you understand. So listen, first one, answer. How to do that? We have to write these in the form of a table. That seems easy. Okay, so first step is element. First step is element. What are the elements they give? Next is symbol of element. First is element. Next, symbol of element. Next, percentage of element. Next, percentage of element. Okay. Next, atomic mass. Next, atomic mass of respective element. Next one is moles of elements. Next one is moles of elements. Last one is simple whole number ratio. This is the box. I will charge yours. Okay, students, this is the way to write the bars to calculate the problem. This is what simple whole number ratio. So that one gives the empirical formula. Listen. The compound contains 4.07% hydrogen. Here the elements given are hydrogen and carbon and oxygen. These are the elements. Sorry, not oxygen, chlorine. These are the elements, which are the hydrogen, carbon, chlorine. Symbol of hydrogen is H, symbol of carbon is C, symbol of chlorine is Cl. That is second step. First one, writing the name of the element. Second one, symbol of the element. Third, percentage of element. Here they mention what the hydrogen is present in what? 4.07%. Right? 4.07. Next, they given carbon as 24.27%. And last one is 71.65%. So percent, no need to write percent because already we mentioned here. Next one, students, we have to put the atomic mass of the elements. The atomic mass of hydrogen is how much? 1. Okay, atomic mass of carbon is 12. Atomic mass of chlorine is 35.5. Okay, next one is mole of the element. That means this percentage divided by atomic mass. This is the formula. Percentage divided by atomic mass. Understood? So if you divide this one is percentage is 4.07 divided by atomic mass 1. Correct? Next here percentage is 24.27 divided by 12. Next 35.5 divided 71.65 divided by 35.5. You just write the answers here. You know 4.07 by 1 means that is 4.07 only. Next 24.27 divided by 12 means it is 2.022 only. 71.65 divided by 35.5 means that is 2.108. This is the value. Understand? Initially what you are doing? First, until here the given data we have to take the calculation process start from there. Here students, initially the element symbol, their percentage they were given in that problem. Next, the atomic masses that we know already. And next one is mole of the element, that is percentage abundance divided by atomic mass. Given mass divided by atomic mass gives number of moles. Okay, so that is 4 to 2. In that, the ratio round up the lowest value. Here 4.07 is there, 2.0022 is there, 2.108. Among those three, this is the smallest value. This is the smallest value. So what is simple whole number ratio? Divide each and every ratio by the small number. That means 4.07 divided by 2.022. Next 2.022 divided by 2.022. Each term is divided by the smallest value. Next 2.108 divided by 2.022. Understand? So students, approximately you don't worry about this. You will get 2 approximately. Then approximately you get 1. This is approximately equal to 1. 2, 1, 1. So this is the simple whole number ratio. That means hydrogen is into carbon is 1, Cl is 1. CH2Cl. This is empirical formula. Here I say empirical formula. What is 2 hydrogen, that is H2, 1 carbon C, 1 Cl carbon C, H2CCl. Remember. So students, they give a molecular mass, but we want empirical formula, molecular formula. From that empirical formula, we can easily calculate empirical mass. Okay, so right here, empirical mass. Empirical mass how much? 2 into hydrogen plus 1 into carbon plus 1 into chlorine. So hydrogen is 1, carbon is 12 and chlorine is 35.5 into 1, 1. So 2 plus 12 plus 35.5. You get students 12 plus 2 14 plus 35 means 49.5. 49.5. So this is what empirical mass. Remember, molecular mass is equal to N into empirical mass. This is the formula. Molecular mass is equal to N into empirical mass. Simply I write because I want some space. So molecular mass is equal to N into empirical mass. M means molecular mass, M means empirical mass. Molecular mass they given 98.96. N we don't know. Empirical mass we calculated from the formula, that is 49.5. So students, N is equal to 98.96 divided by 49.5. This one. So N is equal to approximately 2. So once we got the N value, then we have to calculate molecular formula is equal to N into empirical formula. Okay, so in that N value we know 2, empirical formula we know H2CCl2. Sorry, Cl. So students, if you multiply this, H2 into 2 means H4, C into 2 means C2, Cl into 2 means Cl. That is C2H4Cl2 is the molecular mass of the compound, or molecular formula of the compound. So this entire problem carries 3 marks. In that, if you write only this much, you won't get any marks. For this table, this empirical mass you will get 1 mark. Calculation of N you will get 1 mark. Calculation of molecular formula you will get 1 mark. Total 3 marks. Remember, for calculation of empirical formula, if you did the table right, then only you will get the empirical formula. So for empirical formula 1 mark, because here they said what? It's empirical and molecular formula. So empirical formula 1, N value. This one 1, this one 1. Total 3 marks it carries. Understand? Remember, once again I will explain. So students, the questions they directly give us the percentage and also what are the elements present in the compounds. Okay? So here hydrogen they given, carbon they given, chlorine they given, and their percentage they given. Here the first step is writing the elements and their symbol and their percentage given with the atomic mass. The calculation part starts from here. What? The percentage divided by atomic mass, that is number of moles. In that number of moles, the smallest molar value or the smallest mole we have to select, and each mole is divided by the smallest term, and that is made up to approximate value. That means simple whole number ratio 2, 1, 1. So this is empirical formula. with respect to that. So with respect to hydrogen 2 is there, so H2. With respect to carbon 1 is there, 1. With respect to chlorine 1 is there, 1. So that is the empirical mass formula. Once we got the empirical formula, we have to calculate empirical mass by this way. You know how to calculate mass? Okay. So once we got the mass, they already given molecular mass. By using this formula, we have to calculate n value. Once we got the n value, then we can easily find out molecular formula. Understood? So students, this table remains. I'll let this table on this board like this only. I simply exchange the values here. Then you'll understand. Okay? The process is same for all. So I'll take the second example. Okay. So student, second problem. An organic compound containing carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen gave the percentage. Gave the percentage of carbon is equal to 40.687%. 40.687%. Next, hydrogen is 5.085% and oxygen is 54.228%. The vapor density of the compound is 59. Calculate molecular formula of compound. Okay? This. So here another one formula will come. That is what? They given vapor density, not molecular mass. One relation is there, molecular mass with respect to vapor density in the calculation answer. So first listen students, what are the elements present in the compound? They said one is carbon, another one is hydrogen, another one is oxygen. Correct? So carbon symbol is V, hydrogen symbol is C, hydrogen symbol is H, oxygen symbol is O. And the percentage of carbon they given 40.687. Hydrogen they given 5.085. Oxygen they given 54.228. This is the percentage which is given in what? The question. And we have to write atomic mass. Atomic mass of carbon is 12, hydrogen is 1, oxygen is 16. This is what we have to do for our need. Okay? So later we have to calculate, students, the the moles of the element, that is percentage divided by atomic mass. So that means 40.687 divided by 12. Next, 5.085 divided by 1. This one, 54.228 divided by 16. We have to write the answer here. Okay, here we will get approximately 3.389. I just calculate, then you get the answer. Understood? So remaining the ratios are divided by what? Smallest values. That means here 3.39 divided by 3.389, and this one 5.085 divided by 3.389, and this 3.389 divided by 3.389. So students will get the answer. This one has approximately initially this one is 1 we will get, and 5.085 divided by 3.389, that is 1.5, and this one is 1. So students, you know, these must be present in simple whole number ratio. Understood? These must be present in simple whole number ratio. That means these cannot be in the form of 1.5, 2.5 like that. Understood? So this 1.5 is written as 3/2. Correct? So the balance is, if each term is multiplied by 2, then we will get 1, 2, 3, 2. This is the empirical formula. Understand what we did here? Here this is 2, 3, 2. What is the reason for that? Here the ratio we got is 1.5. 1.5 is not, it cannot be calculated in the empirical formula, as we know. Always the compound should be present in a whole number ratio. To make them perfect, each term is multiplied by 2, because 1/5 nothing but 3/2. Understood? That is 2, 3, 2. I hope you understood. Okay, so this is the empirical formula. That means what? So carbon is there, first one, that is C2. Next hydrogen is there, 3. Oxygen is there, 4. C2H3O2. This is the one empirical formula. Next, calculate empirical mass. How? 2 into carbon plus 3 into hydrogen plus 2 into oxygen. Here carbon atomic mass is 12, hydrogen atomic mass is 1, oxygen atomic mass is 16. Okay, that means 24 plus 3 plus 32. We get 60. Okay, 24, so 59 will get 59. So students, here we don't have molecular formula, but we have vapor density. So one relation is there. What it is an right here. Molecular formula, molecular mass is equal to 2 into vapor density. Here vapor density they given, that is how much? 59. So 2 into 59 means how much? 118. This is what? Molecular mass. Because this is the relation. Molecular mass is equal to 2 into vapor density. So students, here molecular mass we have 118. N value we don't know. Empirical mass we have 59. So N is equal to 118 divided by 59. That is 2. So N is equal to 2. Okay, so if N is equal to 2, then we can easily calculate molecular formula. So molecular formula is equal to N is 2 into empirical formula, that is C2H3O2. So molecular formula is C 2 to the 4, H 3 to the 6, oxygen 2 to the 4. This is molecular formula. If you want to calculate whether it is right or wrong, you just calculate the molecular formula of this. That is this carbonyl 4 times 12 4s are 48 plus oxygen hydrogen 6 times, and this is 64. Okay, this one is 6 plus 4 10 plus 8 18, 6 plus 4 10 plus 7 118. That was the molecular mass. Molecular formula is equal to molecular mass. You know that. If you get this value, then your answer is correct. Understood? So this is another problem. Remember one thing, students, in this problem, if here any fractions are there like 1 by 3 and not 1 by 3, 0.33 is there, that is taken as 1 by 3. If 2.5 is there, that is taken as 5 by 4. Understood? And if that 1.5 is there, that is taken as 3 by 2. Like that. Understood? That ratios are very, very important to get, because these present in simple whole number ratio. This is second problem. Okay? So the next one is, these problems, whatever I'm doing on the board, is very, very important. Okay, so the next one is, determine the empirical formula of an oxide. Determine the empirical formula of an oxide of iron. Oxide of iron which has 69.9% iron and 30.1% oxygen. 30.1% oxygen. That is specially dioxygen by mass. Dioxygen by mass. Remember students, here the elements they given is what? Iron as well as oxygen. Iron symbol is Fe, oxygen symbol is O. Atomic mass of iron is 56, that is 55.85, approximately 56 you may take, and this one is 16. Okay, next one you have to do atomic mass, this one is percentage abundance, that is almost 69.9. This one is 30.1. Here it is 55.85. This one is 16. Next one you have to do the percentage abundance divided by that atomic mass. So students, then you get 69.9 divided by 55.85. Next, 30.1 divided by 16. The approximate values you will get is 1.25 this one. This one is 1.88. Remember, after decimal point, at least consider 2 digits. That is 1.25 and 1.88. Okay. So the next one is, this is the simple ratio. So each ratio is divided by that. 1.25 divided by 1.25. This is 1.88 divided by 1.25. So students, here you will get the answer 1, here 1.5. As I told you, if 1.5 is there, that is considered as 3 by 2. To make them into all number ratio, each term is multiplied by 2. This will get cancelled. This is 2. This is 3. This is the empirical formula. Fe is there in 2. Fe2 is 3. Fe2 4. Only this is the empirical formula. Here is that only to determine empirical formula, not empirical mass, not analytical mass. Just an empirical formula. They didn't given any molecular mass here to calculate any value. If they ask only empirical formula, you just compare Fe2 O3. Understood? The question is also very, very important. So the last problem of the students, that is fourth problem, which is given in NCERT. This is the last problem in this calculation. Fourth one. An organic compound contain 57.14% carbon, 6.16% hydrogen, 9.52% nitrogen, and 27.18% oxygen. Calculate molecular formula if the molecular mass is 294.3 gram. Okay, so here the molecular mass they give this one. So students, first one, they give 4 elements here. One is carbon, another one is hydrogen, another one is oxygen, nitrogen, last one is oxygen. Correct? Okay. So the symbol of carbon is C, hydrogen is H, nitrogen is N, oxygen is O. Next, percentage of carbon they given is 57.14. The percentage of hydrogen they given is 6.16. Nitrogen is 9.52. Oxygen is 27.18. Correct? Next, atomic mass of carbon is 12, hydrogen is 1, nitrogen is 14, and oxygen is 16. The next thing is what? Divide this percentage by this atomic mass. Understand, students? So this one is 57.14 divided by 12, 6.16 divided by 1, 9.52 divided by 14, 27.18 divided by 16. Individually, we have to get. Then we will get the answer 4.76 for this. And next, 6.16, 0.68, 1.698. These are the values after the division of these terms. Understand? So among these students, the smallest value is this, of course, no doubt. Then the remaining terms is divided by this value. That is 4.76 divided by 0.68, 6.16 divided by 0.68, 0.68 divided by 0.68, 1.698 divided by 0.68. Then we will get the approximate values as 7, this one will get 7, 9, 1, and this one is 2.5. This one is just 2.5. As I told you, if we get 2.5, it is taken as what? 5/4. 5/2. This one is taken as what? 5/2. Understand? Then the answer is, this is 14, this is 18, this is 2, this is 5. So students, here the empirical formula is carbon 14 and hydrogen 18, nitrogen 2, oxygen 5. This is the empirical formula. Understand? Next, calculate empirical mass. Okay, 14 into carbon plus 18 into hydrogen plus 2 into nitrogen plus 5 into oxygen. That is 14 into 12 plus 18 into 1 plus 2 into 14 plus 5 into 16. Okay, then you will get 12 into 14 is 168 plus 18 plus 28 plus 180. Then you will get, students, approximately 294. You get approximately 294 grams. This is what? Empirical mass. That is empirical formula. Then molecular mass they are already given 294.3 into n into empirical mass we calculated, that is 294. So n value becomes approximately 294.3 divided by 294. That means n is approximately equal to 1. If n is equal to 1, then the molecular formula is 1 into C14 H18 N2O5. That means C14 H18 into O5. Both molecular formula and empirical formula is same. Understood? So this is how about the calculation of empirical and molecular formula. The procedure is same for all the questions. There will be percentage abundance, you have to take atomic mass, percentage divided by atomic mass, there is simple ratio, smallest ratio divided by overall ratio. Okay, then the simple ratio. That simple ratio gives empirical formula. From empirical formula, we have to calculate empirical mass. From that, we can calculate n value. Once we got n value, multiplying the empirical formula with n, we will get molecular mass. Okay, this is very important because all these 4 problems carries 3 marks, and only these 4 problems are often asking in the examination. Only these 4, among them the first one, which is hydrogen carbon Cl, is very important. Okay, thank you.